The indefinite integral. Calculus is built on two operations, differentiation and integration. In this video, we will see how integral calculus is closely related to the differential calculus presented in the previous videos. Differentiation allows us to compute and study the instantaneous rate of change of quantities, and tangent lines and their application and importance extend far beyond these topics. Integration has a large number of useful applications as well. It allows us to compute the area under a curve and find volumes of revolution. Of course, their application and importance extend far beyond areas and volumes. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It is very important for the continuity of this channel. Like every other mathematical operation, the process of differentiation may be reversed. Let's see how it works. Suppose we were asked to find a function f of x whose derivative is 3 times x squared. In other words, 3 times x squared is the derivative function of f of x. In order to obtain the function f, we must reverse the power rule for derivatives. To use the power rule, we multiply the variable's exponent n by its coefficient k, then subtract 1 from the exponent. If the coefficient is 1, then the exponent will become the new coefficient. To reverse this process, reverse the order of steps and reverse the math within each step. Here's how it works. Increase the power by 1, then divide by the new power and simplify. In short, the 2 becomes a 3, then divide by 3. A function f of x whose derivative is 3x squared is called an antiderivative or primitive of the derivative function 3x squared. Are you a little confused? Then we will solve some more examples. We are asked to find a function g of x whose derivative is 8x cubed. The derivative function of g is 8x cubed. To reverse this process, reverse the order of the steps and reverse the math within each step. Increase the power by 1, then divide by the new power and simplify. In short, the 3 becomes a 4, then divide by 4. A function g of x whose derivative is 8x cubed is called an antiderivative or primitive of the derivative function 8x cubed. We now are asked to find a function h of x whose derivative is 1 divided by x squared. The derivative function of h is 1 divided by x squared. In this case, it is better to work with the negative exponent. To reverse this process, reverse the order of the steps and reverse the math within each step. Increase the power by 1, then divide by the new power and simplify. In short, the minus 2 becomes a minus 1, then divide by minus 1. A function h of x whose derivative is 1 divided by x squared is called an antiderivative or primitive of the derivative function 1 divided by x squared. The process of finding antiderivative or primitive is the reverse process of differentiation and is called antidifferentiation or integration. In short, This is the process of undoing differentiation. Now let's talk about the notation of primitives or antiderivatives. We usually represent functions with lowercase letters such as f, g, or h. Their antiderivatives are denoted by uppercase counterparts such as f, g, or h. So we can rewrite the last statements as follows. A function uppercase f is an antiderivative or primitive of lowercase f if uppercase f prime equals lowercase f. You should note that f is called an antiderivative of the derivative function rather than the antiderivative of the derivative function. To see why, observe that the function f is not unique and that an infinite number of antiderivatives could exist for a given function. For example, each of the following is an antiderivative of 3 times x squared because the derivative of the constant is always 0. So every such function is an antiderivative of 3 times x squared. Any function of the form x cubed plus or minus c, where c is any number, has a derivative of 3 times x squared. You could see this with the other examples as well. The notation used to represent all antiderivatives of a function f of x is the indefinite integral symbol written as follows. The indefinite integral of f of x written as the indefinite integral of f of x with respect to x is the family of all antiderivatives of the function f of x. In particular, if uppercase f is an antiderivative of lowercase f, then the integral of lowercase f with respect to x is uppercase f plus c. C is the constant of integration. The expression is read as the integral of f of x with respect to x. The function f of x is called the integrand. The quantity f of x plus c is the integral of f of x with respect to x. All of the differentiation formulas which you have learned yield corresponding integration formulas. It's just a matter of reading things in reverse. In short, you can obtain integration formulas directly from differentiation formulas, as shown in the following summary. Basic rules for integrating common functions. This rule states that the indefinite integral of a constant function with value k with respect to x equals k times x plus c, since the derivative of k times x plus c equals k. Look at the example. The indefinite integral of 5 with respect to x is equal to 5 times x plus c. This rule states that when integrating a power of x, we add 1 to the exponent and then divided by the new exponent, since the derivative of x to the power of n plus 1 divided by n plus 1 is equal to x to the power of n. Look at the example. To calculate the infinite integral of x squared, we apply the power rule for integration. We add 1 to the exponent and then divide by 3. So the indefinite integral of x squared is x cubed divided by 3 plus the constant of integration. This rule states that the indefinite integral of the constant times a function is the constant times the indefinite integral of the function, since the derivative of the constant times a function is the constant times the derivative of the function. Look at the example. The indefinite integral of 5x cubed is equal to 5 times the indefinite integral of x cubed. We now apply the power rule for integration. We add 1 to the exponent and then divide by 4. So the indefinite integral of 5x cubed is 5 times x to the power of 4 over 4 plus the constant of integration. This rule states that the indefinite integral of the sum or difference of two functions is the sum or difference of the indefinite integrals of two functions, since the derivative of a sum or difference is equal to the sum or difference of the derivatives. Look at the example. We can proceed by splitting the integral, then we integrate term by term. The integral of the exponential function is equal to the sum of the quotient of the exponential function divided by the natural logarithm of the base, since the derivative of a exponential function is equal to the power itself times the natural logarithm of its base. If the base is Euler's number, so the exponential function is its own derivative and its own integral. To solve item E, we integrate term by term using the formulas for integration. The integral of the multiplicative inverse of x is equal to the sum of the natural logarithm of x and the constant of integration, since the derivative of the natural logarithm of x is 1 over x. The integration of the sine of x function with respect to x is equal to the sum of the negative cosine of x and the constant of integration, since the derivative of the cosine is minus sine. The integration of the cosine of x function with respect to x is equal to the sum of the sine of x and the constant of integration, since the derivative of the sine is cosine. You should try to solve the next examples yourself and then check the answers. Obviously, there are many other integration formulas besides these.